Okay, let's try this example now. We're going to put it into context, and we're going to set up the problem algebraically using the permutation formula, and then we're going to solve it. So since we're going to use the formula, I'm going to go ahead and write it here. That's going to be n factorial over n minus k factorial. And let's read. It says, find the number of ways 7 statues can be displayed if 11 statues are available. We have 11 statues and we want to pick 7 of them to rearrange. So the setup here is going to be 11 P7, and then that's going to be 11 factorial all over 11 minus 7 factorial. And here we're going to get 11 factorial all over 4 factorial. And we're going to expand the numerator. So we have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. We're going to stop at 4 factorial so that we can cancel it with the denominator here. So these ones are going to cancel out. And now we can multiply these 7 terms here. 1, 2, 3, 4, 5, 6, 7. So let's multiply them. And here we get a total of 1,663,200. So that would be the total. That would be the total number of permutations here. So that's how you would set it up algebraically. If it doesn't ask you to set it up algebraically, you could have just used the placeholders. So you would have 7 placeholders, and on the first placeholder you only have 11 choices, on the second one 10, 9, 8, 7, etc, etc. But here we're trying to practice using the permutation formula. So let's go ahead and try one more. Here it says a class has 9 students. Find the number of permutations for first, second, and third place in the art show. So now here we have 3 positions. Here we have first, second, and third. And we have a total of 9 students. So from 9 students, we want to pick 3 places. So we have 9P3. And then that's going to equal 9 factorial all over 9, subtract 3 factorial. So we have 9 factorial all over 6 factorial. Let's simplify this. 9 times 8 times 7. We're going to expand up to 6 factorial so it cancels out with the denominator. And now we have 9 times 8 times 7. And that gives us a total of 504. So again, just to reiterate, you don't necessarily need the permutation formula to get the answer. You could have just used the placeholders. You would have read here that we have first, second, and third. Have 3 placeholders and then start counting down. However, what I'm trying to assess here is your ability to make sense out of a problem and convert it into an algebraic equation. So that's I'm putting more importance on that than necessarily just spitting out the answer. So try the last set of problems, and I'll see you in the next lesson.